So here we see the setup, which includes an old phone, a battery which I'm going to use to power the phone, a circuit that limits the current and divides the voltage so that the microcontroller does not get too much voltage, and then also the Arduino connected to my laptop, which will be doing the signal processing. On the screen we can see the program for the signal processing, and if I press F5 it should run. So two graphs will pop up on the screen. The top one here is the raw data from the ADC, and the bottom one is filtered for 50 Hz in DC noise. This number here is the frequency of the sampling, which is hovering around 1000 Hz, which is about the value that we set it to. This part here will be showing the button that has been pressed on the phone. So I'm going to plug in this battery and we should see a transient on the screen. There you go. So it is showing that the button 7 has been pressed, but that's just a result of the transient. So we should try number 2. So as we see, number 2 is shown up here. We should try number 8. That's correct. Hash 7 3.
If you look at a plot of the two graphs in the frequency domain, the top being the unfiltered signal and the bottom being the signal filtered out for 50 Hz noise and the DC component, we can see for the button 1 being pressed that the signal is a lot less noisier, and we can see two fundamental peaks for the button 1. Each button had their own two fundamental peaks matching up to the rows and columns. We used these peaks to figure out what button is being pressed. Here we can see the two signals in real time in a time domain, the top again being unfiltered and the bottom being filtered. A range of buttons are being pressed, but as we can see from the signals that the unfiltered signal has a much higher amplitude compared to the filter signal, therefore we have a much cleaner signal after all our IIR filtering.